Hey there, Stanley Lake Physics. Okay, today we are going to be talking about motors and generators. You've already learned a little bit about motors, but what we've got here is a basic situation for motors. This is actually from a drill. And so what we've got here is a permanent magnet that is created, and that permanent magnet is created because we run an alternating current through here. It's converted to a DC current inside of there. And on the inside here, we've got more coils of wire. And this would be the armature that's on the inside there. And so when you have a permanent magnet here, which is induced, is created, then you've got a magnet on the inside there with a coil of wires, it causes the drill to spin. Okay? So by providing electricity to that, it's going to cause that drill to spin for us. But now, what would happen if we did the opposite? What if you took the end of the drill and you spun that? Right? What happens? Okay, so we put electricity in here, and then you've got the drill, you push the trigger, and it spins for us, right? But what if instead we didn't have electricity running in here, and we chose to spin this? We took mechanical energy instead of taking electrical energy and converting that to mechanical energy to be useful for us. We take mechanical energy and we spin that. What's going to happen? Well, at that point, now you've got yourself a generator. Okay, so we've got here a generator, and inside of here we've got all the same basic parts as here. We've got a permanent magnet, we've got a coil of wire, and a little hand crank here, right? And so with this hand crank, what I'm going to be able to do is just, as I turn this over, it should be generating electricity because I've got a coil of wire with a permanent magnet in close proximity, right? So as I turn this over, you'll see that the light bulb goes on. If I turn this slower, the light bulb is dimmer. If I turn this faster, the light bulb is brighter, indicating that it is getting more power. Okay. We also have a larger version of this, which shows some of the parts and pieces. We've got a permanent magnet right here, and on the very inside, you can't really see that, but on the inside, you're going to have a coil of wire that is going to be there, right? And again, if I just go ahead and take this and start cranking that over, we've got ourselves light. Okay, now, what we're doing is we are taking a motor and kind of reverse engineering it. And somebody may say, well, yeah, but motors and generators are very different. Well, if we wanted this, instead of to be a generator, we wanted this to be a motor, we would just need to hook it up to a power source. So if I do that, and I use this power source, I'm going to turn the voltage down a little bit. So I turn this on. Less voltage, more voltage. Now suddenly, I took a generator and I turned it into a motor, right? Showing that they are not different. They are one and the same, right? They have all the same parts and pieces on the inside. And so if we think about it like a fan, okay? A basic fan, right? You plug that in. On the inside here, it has got all the same parts and pieces as we see here. And when you run electricity through it, it is going to turn the end of the fan, which is where the fan blades are attached to. Everybody's familiar with that. But you're also pretty familiar with wind turbines. And if you go out towards Boulder, right, there's some wind turbines out there. And the way that a wind turbine works is instead of plugging this in and having electricity go in and having the permanent magnet and the electromagnet spinning the fan blades, instead you've got mechanical energy in the wind pushing those fan blades around, generating electricity at the end. Okay? So that is how a wind turbine works. It's basically a large fan. If you could hook up a wind turbine to a big enough power supply, it's going to turn those blades around. So one of the things that we talk about with generating electricity is that when you have a power plants are really just different ways to take mechanical energy, which is usually in the form of steam, and get them to turn a fan blade, right? So all we're doing is just like a tea kettle, right? You go ahead and brew some tea, or you got some hot water going. Steam comes shooting out of that tea kettle. And it's that steam that we're trying to get at, right? That steam has a lot of force behind it. And so you need something to boil the water. And you could use coal, you could use oil, you could use natural gas, you can even use nuclear energy to get that water to boil. Once that water boils, you get steam. Then it goes past a fan blade, which we call a turbine at that point. And imagine having steam shooting up at high velocity and spinning these fan blades around, generating electricity at the end. So that's how a generator works. It is all the same components that a motor is going to have. We just kind of reverse engineer it. Use mechanical energy to create electrical energy instead of taking electrical energy and creating mechanical energy. So there you have it, Stanley Lake. That is our little mini lesson on motors and generators. Hope you learned something and have a great rest of your day.